So right now I'm going to do a quick rundown of the study guide for Unit 3. Make sure you note as you go through for each of the different skill sections, the practice problems that I've highlighted from each of the unit practices. Those problems that I've highlighted are most directly related to the problems that you will see on the test. So starting in section 1, differentiating functions. So in the first one we have f of x equals f of x times cotangent of 6x. First of all, we said two different functions with an x in them, and we said times. So we have to be using our product rule. We'll do derivative of the first times the second left alone plus the first times the derivative of the second. Now on derivative of the second, that's one we read as cotangent of 6x, so we have to apply the chain rule. With an outside, which is cotangent of the inside, and the inside is 6x. So going back into our product rule, derivative of cotangent is negative cosecant squared of the inside 6x times 6 from derivative of the inside function. Putting it all together, best thing we can do on this, we can go ahead and factor out a 5 if we choose to do so. Wouldn't be a bad idea. Which will give us a cotangent of 6x here. The negative sign in the 6 will make this a minus 6 cosecant squared of 6x. And we'll make sure we don't forget the x from right here. In problem 2, p of x equals 6x squared over 3x minus 2. So this has to be a quotient rule problem. And so p prime of x will equal low d high, bottom times derivative of the top, 3x minus 2 times 12x, minus the top function, times derivative of the bottom, which will just be 3, all over 3x minus 2 quantity squared. We can expand everything in the top, 36x squared minus 24x, all minus 18x squared. And that's going to be over 3x minus 2 quantity squared. Combining like terms and factoring would give us a 6x times 3x minus 4 all over 3x minus 2 quantity squared. On to problem 3. G of x equals tangent to the 6th power of 3x squared minus x. And recall from class, these are the kinds that we want to rewrite just to make sure there's no confusion. This is that entire tangent function raised to the 6th power, which means we have to be thinking chain rule, with an outer function being the inside of the 6th power, and the inside being tangent of 3x squared minus x. And so differentiating, g prime of x would be the derivative of something to the 6th power is 6 times that something raised to the 5th power times derivative of the next function. Now this tangent is its own chain rule because you read it as tangent of 3x squared minus x. So the outside is tangent of the inside, and the inside is 3x squared minus x. We've got to get all those pieces in there. So derivative of tangent is secant squared of our inside function, and then times derivative of 3x squared minus x, 6x minus 1. Pull some things out to the front, leave the trig functions at the end of the function, we get something like this. Leave that constant 6 here, leave everything nice and factored, and then generally we'll go in order of power. Go secant squared of 3x squared minus x, and rewrite that tangent the way we normally see it. Tangent to the 5th of 3x squared minus x. And problem 4. b of x equals 5 times the quantity negative 4x cubed minus 7, all raised to the 8th. Have to notice that this is going to be another chain rule problem with an outside function that is 5 times the inside to the 8th. Remember, we don't need to worry about product rule because that is a constant as part of our product and not another function with an x variable in it. And the inside is negative 4x cubed minus 7. So derivative of b of x. Derivative of 5 times something to the 8th is going to be 40 times that inside function to the 7th power times our derivative of the inside, which would be negative 12x squared. Pulling all monomials out to the front, the negative 12 times the 40 will give us a negative 480 x squared times the quantity negative 4x cubed minus 7 to the 7th power. Our next section that we should be expecting, tangent and normal lines. So in problem 1, find all x values for which the curve y equals x to the 4th minus x squared has horizontal tangents. We gotta realize that means where our derivative equals 0. So getting y prime here, we're gonna get 4x cubed minus 2x. We want to set that equal to 0. So always a good habit to get into, factoring. Factor out 2x and leave us with 2x squared minus 1 equals 0. Right away, one factor is going to tell us we have a horizontal tangent at 0, and we'll have to solve on the other one. We get 2x squared minus 1 equals 0, so x squared has to equal 1/2. And just remember, when we get this, it's going to be plus or minus the square root of 1/2, or plus or minus square root of 2 over 2. So 3 different solutions coming out where our curve will have a horizontal tangent. In question 2, write the equation of the line normal to h of k equals 4x times x minus 3 quantity squared at x equals 3. So the big thing is remember for a line normal. We're going to need x, which we have is 3. We're going to need our h of 3 value to get our y value. And we should note, if we put a 3 in here, it'll actually work out really nicely because 3 minus 3 is 0, and that 0 in the product is going to turn the whole thing into 0. So we've got x, we've got y. We also need a slope. Remember, for that, we're going to need h prime of 3 so that we can do the opposite reciprocal to get the normal slope. In order to get h prime of 3, we're going to first need h prime of x. Remember, we said 4x times something else with an x, that's got to be a product rule. So we'll do derivative of the first times the second left alone. So 4 times x minus 3 to the third plus the first left alone, and derivative of the second, that's another chain rule. So we've got x minus 3 to the third will be 3 times x minus 3 to the second times derivative of the inside, which is just 1. And don't worry about simplifying here because our whole goal was just to plug in a 3. So I feel pretty confident that we can do that right now and be fine. And notice how both products that you have in this problem have that x minus 3 in it, which means they're going to have a 3 minus 3. Both parts have a 0. So both parts of this sum are actually going to be 0, and h prime of 3 turns out to be 0. And we have our tangent slope. Just remember that is tangent. Well, if we try to do opposite reciprocal, we're going to end up with negative 1 over 0, which is undefined. And that's okay because undefined should lead us to realize that our normal line has to be a vertical line. And a vertical line is always defined by the x value, and the x value we originally had was 3. So our normal line is x equals 3. Problem 3. Write the equation of the line tangent to the function g of x at x equals 4, given g of 4 equals 2, and g prime of 4 equals negative 1/3. Remember, for a tangent, we need 3 things, just like with the normal. We need our x value, which we have. We need our function evaluated at that x, which we were also given, and we need our tangent slope, which we have from that last piece of information. We actually already have everything we need to write the equation of this line if we just know how to read the given information, which means we can already drop everything right into our point slope form. Y minus 2 equals negative 1/3 x minus 4. Or if you're someone that prefers slope intercept, and we should be good with both, we'll get a negative 1/3 x plus 14/3. Question 4. Does the line tangent to f of x equals 3x squared minus 6x have a slope of 12 when x equals 3? Show work to justify your answer. Well, slope of 12 when x equals 3, all we need to think of for that is, does f prime of 3 equals 12? That's all we're being asked to prove. So let's first get f prime of x, which would be 6x minus 6, and f prime of 3 would be 6 times 3 minus 6 equals 12, and based on our work, we can say yes. Moving on to our section with physics, rates of change, and looking at question 1 there. We have a model for the amount of money a company has in hand over the course of a year, and it's modeled by this A of t function, where A of t is 5,000 t squared minus 2,500 t plus 15,000. T is time in months, and it's anywhere between 0 and 11. Reason for that, we're going to keep January as being time 0 and December as time equal to 11. So we want to know when the amount of money for the company is at a minimum. Well, it's just like the problems we've been looking at where we talk about things like max height when something's in motion. And the idea is, the only way that you can have a minimum amount of money, think about your A of t function. It's a quadratic function, so it would be a parabola. And the only way I could have a minimum for that function is when my slope is 0. So first thing we're going to do is we're going to find A prime of t, which would be 10,000 t minus 2,500, and then we're going to set that equal to 0. And so we'll get 10,000 t equals 2,500, and t equals 1/4 of a month. And so the company reaches its minimum amount of money relatively early on in the model. And the other part of the question was, how much money do they have at that time? Well, the only thing that gives me the amount of money was A of t. So it's just asking me, at that minimum value for time, what is my actual amount of money? I want A of 1/4, which would be 5,000 times 1/4 squared minus 2,500 times 1/4 plus 15,000. And if you want to try it out by hand, or just this one you can put right into a calculator, don't plan on having to simplify anything that's complicated for your test. A of 1/4 would equal $14,687.50. And part B, describe what is happening to the amount of money the company has in June. When I say what is happening, I'm talking about how it's changing. So it's kind of the same idea as thinking about movement at rest. And so I'm going to look to the derivative for this part of the problem as well. And what I want to think about is, when I say what's happening in June, we got to give a time value for that. And if January is the 0 month, 5 months later would be t equals 5. It's really just asking me to do A prime of 5 and interpret my result. So we have 10,000 times 5 minus 2,500, which will equal 47,500. And the units on that, you got to think about the units for the overall problem. Think about the units for your output versus your input. So the output was money, so it was in dollars per month. And what that means to us, in June, the company's money was increasing because that is a positive value. And problem 2 out of this, working with a table. Notice that this is a table that describes velocity versus time. Velocity is given in meters per minute, time in minutes. Note that velocity is a differentiable function, which means it is also continuous. And so at part A, at time equals 0, is the particle moving to the left or right? Well, movement always comes from the velocity function itself. The right would mean that we were talking about something greater than 0. Right's generally a positive direction. And left would mean less than 0. And all I want to think about is what's going on at 0 itself. Thinking about v of 0. which we know from the table is -4. So since v of 0 is negative, the particle is moving left at t equals 0. Part B, is there a time during the time interval 0 to 12 when the particle is at rest? And we want to justify our answer as well. So at rest, for us, that's a phrase meaning motion, and it's the idea that the velocity equals 0. Looking at the table, we have two spots where the sign changes, from -4 to +2, and from +5 to -3. And what we have to think about is we're trying to prove a value for the function on our interval. And the thing that helps us prove values for a function is the intermediate value theorem. So let's get our setup to the intermediate value theorem. Since v of t is differentiable, and you might be asking yourself, well, IVT was supposed to be continuous. Well, the idea of differentiability is that if it's differentiable, then it is also continuous. If you only mention differentiable or only mention continuous, it would be perfectly fine. So since the velocity is differentiable and therefore continuous on the interval 0 to 12, and v of t changes signs, that's an easy way for us to break down this problem. We don't need to worry so much about listing that 0 is in between two different values. We can if we want to. So since v of t changes signs on the interval 0 to 12 by the intermediate value theorem, and then just repeat what we were supposed to prove. There is a time on 0 to 12 such that the particle is at rest, or such that v of t equals 0. And the last part, use the data from the table to approximate v prime of 4. With no function, approximates the best we can do. But we don't even have any information about what's going on at 4. So the best we can say, first of all, notice that v prime of 4 would have to be the rate of change for v of t. The best we can do is use an average. We don't have a function to talk about the instantaneous. And so what we're going to do is we're going to use the values closest to 4. We're going to use t equals 2 and t equals 6 and calculate the average rate of change. And so we'll do v of 6 minus v of 2 all over 6 minus 2, or 5 minus 2 over 6 minus 2, which is 3 over 4. Giving ourselves units. Velocity was the numerator, so those units were meters per minute, divided by the time units, which were also minutes, which is going to give us meters per minute squared. And describing the answer in context of the problem, key to say using our approximation, because again, we don't know exactly what's happening at 4. Using our approximation, v of t is increasing at t equals 4 because v prime of 4 is positive. In the last section, what we're calling so-called generic derivative applications. Not giving you defined rules to describe all the functions of your problem. We're just generally showing that you have an f of x function made up of other functions. And for each of these, we want to find f prime of 2. And we have information on g and its derivative at 2, and h and its derivative at 2. So if we start off with f of x equals 3g of x minus 5h of x plus 4x, know that that's three different functions being added or subtracted together. So if we want f prime of x, well, differentiating 3g of x, that'd be the same as 3g prime of x. Minus 5h of x, well, that derivative would be 5h prime of x, and derivative of 4x would be 4. And now it's just substitute the values in. G prime of 2 would be a -1. H prime of 2 would be a -1/2, and this plus 4. And simplifying that down if we choose to, which wouldn't be a bad idea, we would get a positive 7/2, or a 3.5. Question 2, f of x equals -2 times g of x times h of x. You should know that that's going to be a product right there, minus x cubed, which is going to be a totally separate function to differentiate. So f prime of x will equal, now let's go ahead and just attach that -2 to the g of x. So if we did -2g of x as our first times derivative of the second, h prime of x, plus -2g prime of x for derivative of the first times the second left alone, and minus 3x squared from our x cubed. Substituting in 2, we'd have -2 times g of 2, which is 3, times h prime of 2, which is -1/2. I'm just going to combine the plus and minus to make this a minus. 2 times g prime of 2, which is -1. H of 2 is 1. And minus 3 times 2 squared. Again, that all simplified would give us an f prime of 2 equal to -7. In 3, f of x equals g of x divided by h of x. There's a quotient right there. Minus 2g of x. Just an extra derivative being added on that we have to take care of. So f prime of x, let's take care of the big one first. Bottom times derivative of the top, minus top times derivative of the bottom, all over the bottom function squared, plus 2g prime of x. Substituting a 2 would give us a 1 from h of 2. G prime of 2 is a -1, minus g of 2, which is 3, times h prime of 2, which is -1/2, all over h of 2, which is 1 squared, plus 2 times g prime of 2, which is a -1. And f prime of 2 would equal -3/2. And finally, f of x equals g of 2 times h of x. And for this, once we read that word of, we've got to be thinking chain rule. So our outside would be g of the inside, and the inside would be 2 h of x. And so applying our chain rule, f prime of x would equal g prime of 2h of x, leave that inside alone, times 2 h prime of x. Now this one we'll have to do in a couple steps. We got to remember how to use composite functions here. You're doing g prime of 2 times h of 2, and h of 2 was a 1, times 2 times h prime of 2, which is a -1/2. But notice how that's going to make you do g prime of 2 times, now we got a -1 out there, and g prime of 2 was -1. So -1 times -1, f prime of 2 will equal 1. And so that does it for the study guide. Again, make sure don't just trust this. Also look back, the practice problems I prescribed from each section. Make sure we're very clear on how those work. If you want any extra practice, either search for it by name in any sort of search engine, email me, and I'm happy to send you any extra practice that you may want. Please email or come in to see me with any questions you may have, and best of luck studying. Thank you.